Hi everyone, today I'm going to talk about deep learning and accelerated calculation with Debian. So, what is deep learning? In the recent years, we have seen a trend of technology development about artificial intelligence. For example, the emergence of AlphaGo, an artificial agent that is able to play chess. Apart from that, new technologies about autopilot also appeared for the vehicles. And actually, deep learning is a key part of the state-of-the-art artificial intelligence you can see. When we talk about deep learning, it is basically about deep neural networks. The most typical application of deep neural networks is classification. For example, we have an image presenting a cat. We use this image as the input to the deep neural network. And the network will try to crunch many numbers, do lots of mathematical operations, and calculate the probabilities for a predefined list of categories. In our case, the category cat has the highest probability, so our input image is classified as the cat. Now let's take a closer look to the internal of neural networks. A basic deep neural network can be decomposed into a series of network layers organized in a sequential pipeline where the output of the previous layer is used as the input of the next layer. The most frequently used network layers include the convolution layer, which is common to networks that take image as the input, and the linear layer, which performs a affine transformation, and the activation layer, which introduces nonlinearity to the neural network, and the pooling layer, which introduces translation invariance to the deep neural network. When we try to use a neural network, we can immediately identify some performance bottlenecks, for example, the linear layer and the convolution layer. In the linear layer, the core mathematical operation is general matrix multiplication, while in the convolution layer, the core operation is convolution. But the convolution itself is essentially a linear operation, so it can be seen as a special kind of matrix multiplication. So, how do we mitigate such performance bottlenecks and accelerate the calculation? The solutions can be categorized into three groups. The first one is parallelization. For example, OpenMP, which spawns a number of threads at the runtime to calculate the matrix in parallel. The second group is some techniques for optimizing the cache access in order to reduce the rate of cache misses. The third group is hardware accelerations, and there are many available hardware solutions. Now let's look at the first one, single instruction multiple data, namely the vectorized instruction set provided by the CPU. For example, the AVX2 instruction set. However, even if we leverage all the CPU capabilities, the floating point performance is still far not enough for neural network applications. The next one is OpenCL. It is a feasible solution, but OpenCL has a complicated programming model and lacks support from the machine learning communities. In contrast, NVIDIA CUDA is the most mature solution, and it is most widely adopted by the machine learning community, but it is proprietary. To compete with NVIDIA, AMD proposed its own CUDA counterpart named ROCm. The software stack is open sourced, but it is still not mature enough like CUDA. Intel has recently announced their plans for the discrete graphics card, and the software support will base on SQL, which is a high-level programming model for OpenCL. The software stack is also open source and not mature enough. There are also other types of hardware acceleration solutions, such as FPGA, but I'm not quite familiar with them. Given this background, we still have lots of work to do to integrate these libraries and applications into Debian. Actually, I participated in all the works related to deep learning and hardware acceleration in Debian, and I divide these works into 4 aspects. The first aspect is the maintenance of performance libraries and introducing new ones. For example, the fundamental mathematical libraries, including the BLAS and LAPACK libraries. The second aspect is deep learning frameworks. For example, the TensorFlow and PyTorch. The top 2. They are the top 2 deep learning frameworks. The third aspect is AMD Rawcan. It is the free and open source counterpart to NVIDIA's CUDA. And I think supporting AMD Rawcan from Debian is beneficial to the free software community. The last aspect is Intel SQL. It is actually an additional module to the LLVM project, but Intel still has not yet upstreamed their code to LLVM project, so I'm still waiting. Next, I'll give you a brief summary about packaging works for the performance libraries, deep learning frameworks, and AMD Rawcan. Generally, there is nothing special for the packaging work for the performance libraries, but BLAS and LAPACK is an exception. The 2 libraries implemented a number of very fundamental numerical linear algebra subroutines. The corresponding shared objects are the libBLAS and libLAPACK. Actually, there are 2 virtual shared objects managed by the update alternatives mechanism. The fastest open source implementation of BLAS is OpenBLAS, but actually Intel's math kernel library is faster than OpenBLAS, but it is not free, so I registered Intel MKL in the mechanism with the lowest priority. Likewise, the recommended implementation of libLAPACK in Debian is also OpenBLAS, but actually there is a faster free software implementation named libFlame, and currently I'm working on it. So the 2 linear algebra libraries, BLAS and LAPACK, they have some notable reverse dependencies, such as GNU Octave, NumPy, and SciPy. That means there are 2 very important libraries, and their performance can greatly impact the productivity of scientific computing users. Okay, deep learning frameworks. Currently, the top 2 deep learning frameworks are TensorFlow and PyTorch. The blocker for TensorFlow packaging is Bazel, a build system written in Java. It is currently under heavy development, and this is not easy. Preliminary packaging based on Bazel is available on Salsa. On the other hand, the packaging process of PyTorch is a good news. The dependency libraries are already queued in new, and PyTorch itself is also in new. But I have to point out that I have no plan for the CUDA version of PyTorch, but I have plan for the ROCm version once the ROCm compiler is available in Debian. In the Debian archive, there are also some other deep learning frameworks such as Caffe, but nowadays I personally regard Caffe as an educational code base. Apart from this, we also have some plans for other deep learning frameworks such as MXNet. If you are interested in this, you can browse the Salsa page of Debian Deep Learning team. Next is AMD Rawcan. The software stack is open sourced, but they depend on the non-free firmware. Anyway, at least the kernel module is already present in the mainline kernel and is already usable. However, apart from the kernel package, the packaging work for the ROCm software stack is literally from scratch, so it is still under heavy development. If you are interested in the packaging details, you can browse the Salsa page of Debian ROCm team. That is a brief summary of Debian works related to deep learning and hardware acceleration. Apart from that, there are also some interesting issues. For example, can we better leverage the SIMD instruction sets system-wide? In the past, I proposed a project named SimDebian. It aims to bump the ISA baseline in the system default build flags. But currently, this project is stalled because we don't have a definite conclusion about the performance gain from the system-wide build flags. Another example is software freedom issues in the deep learning practice. We had lots of discussions in the mailing lists, and eventually I drafted a machine learning policy. It aims to sort out the issues between the machine learning practice and software freedom. This document project is stable currently, but it is not official. Okay, thank you for listening. I hope the information presented in this talk is helpful.
The first question, I mean, this has been answered already in the Etherpad, but maybe for everybody's, for everybody, is ROCA, or however it's called, packaged? And if not, would it be hard to do? You're still muted.
Okay, let's start the Q&A session. Well, there are only 3 persons.
Question, I mean, this has been answered already in the Etherpad, but maybe for everybody's, for everybody, is ROCA, or however it's called, packaged? And if not, would it be hard to do?
Yes, I have already answered him. I'm Luming, so I have already answered him.
You're still muted.
Yeah. Hello?
Right, I hear you, but I think there's a huge delay.
Yeah.
So, yes, well, if you answered all the questions already on the Ethernet, then, I mean, maybe you can just rephrase your answer. So, I guess you should, there was one mentioning about Basel, so what's the current status, and can you comment on that?
I'm Luming, so I have already answered it. Yeah.
Right, I hear you, but I think there's a huge delay.
Yeah, I think there is some weird delay.
So, yes, well, if you answered all the questions already on the Ethernet, then, I mean, maybe you can just rephrase your answer. So, I guess you should, there was one mentioning about Basel, so what's the current status, and can you comment on that?
Okay, I'm writing the answer.
Right, I hear you, but I think there's a huge delay.
Yeah, I think there is some weird delay.
Okay, so it may be the problem that Lumin is not hearing me via Jitsi, but only via the stream. So there's a huge delay here going on. So I don't see any obvious questions that haven't been answered, but we do have quite a lot of time left, another 5 minutes. So if you want to ask some more questions, please write them on the Etherpad, and we can try to answer them. So I'll leave this open for a couple of seconds for further questions. So we have one more question, which is what was the other library that's faster than OpenBLAS and still work in progress? Okay, so we are slowly running out of time. There was a lively discussion on the Etherpad, and the discussion can go on after this talk. I would like to thank Mo Zhou again for the talk, and the next talk will be in 10 minutes. So everybody, see you. Bye-bye.